Hi there. For the third part of our training class here, we're going to go over the actual tools themselves. We went over the pump and how to read it, the fittings that you can hook it up to, how to set the pressure. We went over the hoses, to check for the safety burst guards, that there wasn't any bends or kinks or exposed steel braiding that you might be able to see, and how to keep your fittings tight. The third part of this is going to be on the tools, and we're going to go over the actual tools and some of the different accessories that are associated with them. But I'm going to hook this up and show you how it runs. Just like you did on your pump, you're going to take the end of the tool, or end of the hose, attach it to your tool, and as you can see, it only hooks up in one way. Now it is fully connected. This power head here will put out about 2,000 foot-pounds, and it does it with a piston that's coming out the end of it. Now I'm going to turn the pump on and show you what it's actually doing when you hit when you actuate the pump. The piston comes out, in and out every time you push it. So every time you push the button, the piston comes out. It will only go so far before it hits top dead end. You have to let go of the button and let it come back and retract. So I'm going to take a standard ratcheting. This is a low profile cartridge, the X-Driver tool. Inside of here, the end of this piston is going to hook up to what's called a drive plate. So in order to make this function correctly, you need to put it on. The tool will snap into it. There's no pins or shrouds or anything else. It's just going to snap in. But remind yourself that that piston is not fully connected yet. You need to take once it is hooked up, you need to turn the pump on and cycle it a couple of times to make sure that the piston grabs the drive plate inside of there. Now it attaches and it ratchets back. Now the tool is fully hooked up and ready to use. So when you get into the tool, this swivel itself, and I'm going to go over a couple of things here. On the tool itself, you have a swivel on the top here. The swivel is not a handle. It's not a rigging point. You should never have your hand rested on top of it. Of everything that moves in here, there's seals inside of here and high pressure hydraulics going in. The swivel is consistently moving and being manipulated. Your hands do not belong anywhere on top of this at any given point. The top of this tool has these little holes you can see there. There is an optional handle, should you require one, that has a screw on it. You can just put it right into the front. One second. You can put it right in. You can screw the handle in so that your hands are always away. From the swivel itself. So the housing on this tool is made of steel. It's strong. It doesn't have any pins or shrouds that are going to fall out of it. It simply clicks into the link that you're using. Once it's in, on the top of this wrench, there is a release button. That's how you remove the tool from the link itself. Put this in, it just clips back in. This is the front of the tool. As you're looking at it right now, this is the front of the tool. If you lay it on its right-hand side, it's going to tighten. If you lay it on its left-hand side, it's going to loosen. And we'll show you that here in a minute. But it's lefty-loosey, righty-tighty. This link fits onto a nut, and you need full engagement. It's not designed for bolt heads. Bolt heads only engage on half of the surface area of the link. This goes on one complete nut, and it reacts right here on the next nut, the adjacent nut to it, around a flange. It goes on one nut and reacts on the next nut. It's virtually a hands-free tool. Once you set it on the application, which we'll show you in a minute, you put it on there and then take your hands off of it. This little lever on the back of the tool is called an accuracy assurance pawl. It does two things. Every time this tool takes a stroke, that holding pawl in there, moving that here. Every time this tool takes a stroke, this holding pawl is going to hold the ratchet. So if you have bolt windup, this tool is going to take a stroke, it's going to hold it, it's going to come back, grab a whole nother set of teeth, and then hit it again so that you have more breakout power when utilizing the tool. The other reason is if you're using it upside down, the tool doesn't hang. You don't have to physically hold your hands up to it. It holds it up. But for that reason, just like a holding pawl on a come-along, if you need to release the tool, you need to advance the pump and hold your finger here until you can push this in, till you can push it all the way in, and then release the button on the pump, and then the tool will come loose. This is not a bullseye for a ball peen hammer. You're not supposed to smack it. As soon as you hit the button on the pump, the piston has an overstroke, just enough to where you'll be able to push that lever down and then let go of the button on the pump and the tool will come loose. That is your release lever if you find that the tool is locked onto the application. If it's locked on, it's doing it on purpose because the bolt is actually wound up. Every tool that we have has a torque chart associated with it. They are all calibrated. This particular wrench, and I don't know if we need to zoom in on, but you have a PSI and you have a foot-pound column. So let's just say that on this flange that we're going to torque up, that we would like to put on 640 foot-pounds. So I'm going to go down the foot-pound column until I find 640, and it says to set the pressure at 3,900 PSI. And we'll go ahead and do that.